different denominators. So 1/4 plus 1/3 you're saying is 7/12?
Yeah.
Yeah? That's exactly what we're doing now. So 7/12 can be written 7/4 times 3, can't it? Yep. Which means these two factors. So that means we can split it up into, something over 4, something over 3, add it together. So sum. Notice the question says write as a sum of partial fractions or write as a sum of fractions. So the tricky part here is finding what this and this would be.
How do you know it's not like 6 and 2?
Where do you get 4 and 3 from?
It could be 6 and 2, yeah.
Or 12?
So can we do it with 6 and 2? So if we have 7/12, what's that with 6 and plus something with 2? Okay, well the maximum, this has to be, like it can't be 2, because 6/12 is 1/2. So maybe this doesn't work then, because that would have to be a decimal, wouldn't it? Yeah. Okay, so it wouldn't work. Well, it could be, yeah, you could do, you probably could do this, could you? That's also a sum of partial fractions, yeah? Okay. So the whole thing is that these two, you're splitting up the original fraction into two fractions that add together. Okay? So you've always done this in reverse. You've done this in GCSE in reverse. If you have 2/x plus 3 plus 7/x minus 1, how do we combine these together? You go, oh, well, the common denominator between these two is x plus 3 times x minus 1, isn't it? And then I can write the numerator as 2 times this and 7 times that. And then what does this create? So on top we have some sort of linear, don't we? We've 2x plus 7x is 9x. And then we've 2 times minus 1, what is it, 21 take away 2? 19 maybe? 19. And then at the bottom we're left with a quadratic, x squared. Yeah, okay. So notice that this is now, used to be the answer, but now it is the question. And can we go back to that?
Yay.
Can we go back to that? So let's do the question that we have been given. Is write this as a sum of partial fractions. So we got 7x plus 1 all over x squared plus x minus 6. So we have this answer, we want to go back. And this time we don't know what the previous fractions were put together. Okay. So the intermediary term, which I rubbed out first, was here. What did that look like?
2 linear on the bottom.
Yeah, so this was factorized, wasn't it? It wasn't multiplied, it was unmultiplied, so factorized. So let's factorize that now. Let's see what we can get. X and what's it going to be? 3 and 2 makes multiply to give 6. So the 3 and, yeah, we happy with that? And 7x plus 1. All right, now, I want this separated. So this was one denominator, this is the other denominator then. So x minus 2 plus x plus 3, and this is where the problem arises.
Yes.
What goes here and here?
Something x plus 3 plus something x minus 2.
Can't you just do 7x plus 1 divided by 1?
Dividing,
7x plus 1 divided by 1 plus 1.
and what will that give?
No idea.
Okay. You could try, they're dividing by something bigger than the numerator. So I'm not sure it's not quite going to work. It's not going to be able to split it up. Like you can divide this by this, but it's not going to split it up into two partial fractions. Now the use for this partial fractions is not necessarily available to us now. A bit like when we did the system of linear equations, we hadn't done vectors yet. And partial fractions is used for integration mostly, because this is often too hard to integrate, whereas this is quite easy to integrate. when we get there. If you've done anyone done integration yet? No. Okay. This is pretty straightforward compared to this. Anyway, how do we get a and b?
It's something x plus 3 plus something x minus 2.
Well, can you do a times x plus 3 times
Well,
plus
yeah.
b times x minus 2 equals 7x plus 2?
Okay. Yeah. Exactly. Yeah. You're both on the right track. So we know that these two are equivalent. I've removed the question just to show that these two are equivalent. Oh, you want it? It's on the screen if you want it.
You just substitute x.
Well, I know that this can multiply back to give this. So if I was given this as the question, and I said combine these two, what would you do? Add these two together. You'd do, all right, my common denominator is x minus 2 times x plus 3. And on the top here, I have a times x plus 3, yeah? Plus b times x minus 2, yeah? And I can simplify that a little bit. I get ax plus 3a plus bx minus 2 all over x minus 2, x plus 3. I have this now. But I already know that the top equals 7x plus 1. And the denominators are already equal, so the only thing... Yes. So, yes, equivalent statements. 7x has to equal... Okay, so ax plus bx, so this, and this... So 7 is equal to a plus b, if I'm just talking about the x's, yeah? And if I just talk about all the constants or normal numbers, 1 is equal to 3a minus 2. Two equations, two unknowns, solve them. And we'll get a and b. So you can get it pretty quick here. A is 1, this is an easy one. 3a is equal to 3, a is 1. And if a is 1, b is...
Isn't it minus 2b?
Oh, I could be wrong. Oh, yes. This is not as easy. I haven't done that. Let's start again. I didn't finish my multiplication. All right, so these are simultaneous. Let's just line them up. So here, that stands for number.
3a equals 1 plus 2b.
So I'm going to just write them. Yeah, you can do it. You can do it by substitution. I'm just going to rewrite them here, a plus b. Maybe I'll multiply the second line by 2, if you like that. You can do this quicker than me, I'm sure. What's this? Numbers. I said no, it's not really the correct term, like it's the constants. The thing without the x, the constants. That is not the correct term. But. So, yeah, this is better. 5a is equal to 15, so a is 3, not whatever we got earlier. A is 3, which means b is 4, yeah? No, have I done it wrong again?
No, I don't know where I went.
Why don't you get different answers when we put the other?
Why do you get different answers?
When we put 3a minus b equals...
Oh,
no.
Why is it
2b now? It works.
2 times b here.
Oh.
Yeah, I just forgot to multiply that too. Yeah, that was my mistake. So now we can write them as partial fractions. A is 3, so 3 over x minus 2 plus 4 over x plus 3 will equal this, which is what we started with, x squared plus x minus 6. You could test it if you want pretty quickly. Multiply this by 3, multiply that by 4, and you should get 7x plus 1, and you will. And that's it. That's partial fractions. So splitting up...
Is that it?
Yeah, that's it, yeah.
Oh, okay.
Not too bad, yeah.
Not too bad. That's the easiest thing we've had all year.